go through a few examples of using the right-hand rule to find the direction of a vector cross product. So we have vectors A and B in a few differential arrangements, and the magnitude of the vector C is given by the magnitude of the vector A, magnitude of the vector B, times the sine of the smallest angle in between them when you put them tail to tail. Now the direction part. The idea is the first vector in the cross product, I'm going to put fingers in my right hand along that direction, so like that. And then I need to move my hand around so I can curl my fingers so that they're perpendicular to the second vector, B, in the cross product. So to get from this direction to the direction that B is pointing, I have to rotate my hand like that. And then I can make my fingers curl to be parallel to B. So I go from A cross B, and that is accomplished with the thumb of my right hand coming out of the plane of the page. And our representation for a vector that's coming out of the plane of the page is a circle with a dot in the center. And that means it's an arrow that you're seeing coming right at you. Okay? So make a little note here. Vector coming out of the page. Alright, so let's try some other ones. For this one, the fingers of my right hand, I want them parallel to the direction of the vector A, and I need to curl my fingers so that they can be parallel to the vector B, which means I have to flip my hand upside down. So now my fingers can curl over to be parallel to B, and there's my thumb going into the plane of the page. So this is giving me a vector C that is into the plane of the page, and our notation for that is a circle with a cross. And that's a vector going into the page. And the interpretation of that is it's a circle with a cross because you're seeing the fletching on the arrow. Circle with a dot is the sharp pointy bit of the arrow coming at you. Circle with a cross is you're seeing the fletching. Right, so let's try another one. So now I want the fingers of my right hand to be along the direction of the vector A, and I need to curl my fingers to be parallel to the vector B. That means I have to flip my hand like that, and then indeed my thumb, my right hand is going into the plane of the page again. So this is also into. So we have an out of, into. And all this is doing is the vector A and B lie in the plane of the page as I've drawn it. Okay, so there are two possible directions that are perpendicular to both A and B, and those are the directions coming out of the plane of the page or the direction going into the plane of the page. Okay. Now, for this last example, I don't have those two directions to choose from. There's an infinite number of directions that are perpendicular to both A and B, because A and B point in opposite directions. That direction is perpendicular. That direction is perpendicular. So is that. When there is an infinite number of choices for the direction perpendicular to both vectors A and B, then the vector cross product vanishes. It's also, you can verify in the magnitude equation. The sine of 0 is 0, the sine of 180 is 0. So the magnitude of the vector C is 0. Okay. And I want to highlight another thing. This is the only case when we're using vectors, where I can set a vector equal to a scalar. Okay. C is a vector. There is a vector symbol on it. There's no vector symbol on the right-hand side, so this is just a scalar. This is the only time I can get away with this, because 0 has no direction. It has no length. It has no direction that I can define for it. So I can set a vector equal to the scalar 0. Okay, so that's okay to do. That's a logical and possible thing that can happen. What cannot happen, I cannot say that vector C equals 1. That doesn't make any sense, because now I am setting a vector equal to a scalar, but there's no direction associated with 1. 1 what? 1 east, 1 along the x direction? There's no way to answer that. So that is going to always earn you a frowny face. Okay? I can set a vector equal to 0 if that is appropriate. I can never set a vector equal to any other scalar. I promise you, whatever the scalar is on the right-hand side, if it isn't 0, it's wrong. So if you ever come to that situation, try to remember this and go back and think about what you did incorrectly. Because you can never tell me that a vector equals a scalar unless that scalar is 0. That's the only scalar that doesn't have to have a direction.